Haycrete, the future of civil engineering?
Our initial idea was to fabricate and test hempcrete. This composite aims to be an eco-friendly building material by combining hemp fibers, lime, and water as a sustainable alternative to traditional construction materials. Hempcrete replaces conventional materials like aggregate and insulation with a blend of hemp fibers and lime. This eco-friendly substitute minimizes environment impact and lowers the carbon footprint in construction. Hempcrete can be used for insulation, non-structural elements like walls, and as a sustainable building material. It offers thermal and acoustic insulation, contributes to carbon sequestering, and encourages the use of renewable hemp resources in construction. Because we didn't have access to hemp, we decided to substitute hay in for our tests. Haycrete comprises hay fibers, cement, aggregate, and water as its main ingredients. The fibrous inner hay fibers provide strength. This combination creates a sustainable and versatile building material. The production process involves mixing the hay fibers with cement, aggregate, and water. This blend is then compacted or molded into the cylinder. This simple yet effective process results in the formation of durable and eco-friendly haycrete. Challenges in haycrete production include the need for careful mixing and curing. Achieving the right balance is crucial to ensure structural integrity and insulation properties. Additionally, haycrete may not be as load-bearing as traditional concrete, limiting its use in certain structural applications.
Our group decided to carry out a test on two different concrete specimens, the first one being a control comprised of a traditional concrete ratio of cement, aggregate, and water, and the second one being our haycrete specimen, which added the hay fibers on top of the other ingredients. One thing we had to be certain of is that we had good testing conditions throughout. So we made sure that we cured our haycrete in an area that had controlled variables such as humidity, temperature, and curing time. These conditions impact the final characteristics of hempcrete, such as strength, durability, and insulation. So it was pretty pivotal that we got this right. Standardizing testing conditions ensures reliable and comparable results across both the control and our haycrete specimen. We decided that the best test for us to use was the compressive load test because this would be a good indication of haycrete's ability in structural situations. This is a crucial evaluation method. In this test, a force is applied to the specimen to measure its ability to withstand compression. This is portrayed as the best stress that it can withstand. This helps determine the material's strength and load-bearing capacity. The compressive load test is essential for assessing the structural suitability of hempcrete in construction applications and provides us insights into its performance under pressure, aiding in the refinement of material formulations for optimal results.
After taking the control specimen out of the cylinder mold, we observed that it was a very standard-looking concrete cylinder. When testing it for the maximum strength, a value of 2,734 psi was observed. When the specimen broke, it cracked throughout the entire cylinder. After taking a look at the haycrete specimen, once taken out of the concrete cylinder, it was noticeably different looking than the concrete specimen. It appeared to be more shiny and the hay fibers were visible. Running a compression test on this specimen yielded a maximum strength of 2,450 psi, and when the cylinder broke, it stayed fully intact and only cracked in small pieces, unlike the control specimen, which cracked throughout the whole cylinder. We believe that the reason for this lack of cracking in the hay specimen is because the hay fibers added a bonding to the concrete, which held it together more, allowing it for it to stay more intact when it failed.
For a more comprehensive view of what our tests look like, we have included a short video of our control being tested to play at the end of this presentation. In conclusion, we first wanted to talk about the context of our findings within the field of engineering. We believe that haycrete is positioned as an eco-friendly solution in sustainable construction, which will contribute to a broader goal of reducing environmental impacts in building practices. It addresses the need for renewable and low-impact materials, aligning with the evolving trends in green construction, specifically for civil engineering applications. We recommend that to enhance the Haycrete application, it should be considered to optimize formulations, refining the construction techniques, and advocating for standardization within the construction of Haycrete. This will promote education and awareness and allow for collaboration to provide regulatory support. There's a lot of future research that could be done with Haycrete, as it is a nuanced material that has not been studied much. We believe that we can do future research in the long-term performance of Haycrete structures, scaling production methods, exploring hybrid materials, conducting life cycle analysis, and understanding the market dynamics for wider acceptance. These efforts aim to advance Haycrete's integration into mainstream construction while providing sustainability and performance. Shown below are the references that we use throughout this study.